All right, y'all go ahead and do the factoring and the math knowledge question. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So the first thing that you're going to do on the factoring is to take out an x, and then you're going to have x cubed plus 1. This is a sum of cubes, so we can use our formula where we'll have 2x plus 1, and then 4x squared minus 2x plus 1. And so this would be your answer for your factoring. For the math knowledge question, which of the following is not a possible value for a probability? You can have a probability ranging from 0% or 0 chance of happening to 100% or 1 out of 1 chance of happening. It's either not going to happen or it's 100% for sure going to happen. You can't have anything greater than 100% for a probability. So the only one of these that's greater than 1 is E. And so E would not work for a probability value because it's greater than 1. You can't have it gonna be 115% chance raining. The most you can have is really 100%. Okay? Anything over that is just an exaggeration. So we are looking at lesson 79 today. We're looking at De Moivre's theorem and then roots of complex numbers. So hopefully you'll understand his theorem after this lesson and you'll understand how to find roots of complex numbers. So, De Moivre's theorem is considered to be one of the most important theorems in the study of complex numbers. It's used a lot whenever you're dealing with complex numbers. If you have z to the n, where z is some number, we can rewrite it as r cis theta to the n. And then we can actually break that out and make it r to the n, and then times cis in theta. So your r goes to the n goes to the exponent on the r, and then it gets multiplied by your angle value. And that's basically what his theorem is. So we want to find 2 cis 30 degrees to the fifth. So the way that we're going to do that, we're going to use his theorem. We're going to say 2 to the fifth, and then cis 5 times 30 degrees. 2 to the fifth is 32. Cis, and then 5 times 30 degrees is 150. And so that would be the answer. Now sometimes they ask you to put it into rectangular form. So I'm going to practice that with you just so that you can see what you would do. You're going to say 32, and then you're going to have the cosine of 150 plus I sine of 150. And so the cosine of 150, anybody remember? Negative square root of 3 over 2. And then the sine of 150 is 1/2. And so now we would just say negative 16 square root of 3 plus 16i. And this would be in rectangular form. So again, sometimes it'll ask you for that. So you need to make sure that you understand how to get it into rectangular form. Now if our angle here had been a 160, you can't put that in rectangular form because you don't know what the cosine or the sine of 160 is. So if they tell you to put it in rectangular form and you get an angle that you don't know, then you've done something wrong. They're only going to get you to put them into rectangular form if it's an angle we should know. So let's look at this one. It wants us to find it, and we're going to put it in rectangular form. Now, this is not in the same CIS form that his theorem is set up to be in. So the first thing that we're going to have to do is to put it into CIS form. The way you're going to do that, 1 plus I. If we graphed that, that would go over to the right 1 and up 1. And so the hypotenuse would be a square root of 2, and this angle would be a 45-degree angle. And so we can write it as the square root of 2, CIS 45 degrees. And then it's to the 13th power. So now we're going to say the square root of 2 to the 13th, and then CIS 13 times 45 degrees. The square root of 2 is the same thing as 2 to the 1/2. And so that's being raised to the 13, and we'll simplify that in a minute. And then CIS, 13 times 45 is 585. But we don't want it as 585. We want it to be less than 360. So I'm going to go ahead and say 2 to the 13 over 2, and then CIS of 225. And so now to put it in rectangular form, we're going to have to break it down a little bit. We'll have 2 to the 13 over 2, and then cosine of 225 plus I sine of 225. So the cosine of 225, negative square root of 2 over 2. And then plus I sine of 225 is also negative 2 square root of 2 over 2. Okay, so here we're going to have negative. The square root of 2 is the same thing as 2 to the 1/2. So when we multiply the 2 to the 13 over 2 times the square root of 2, or 2 to the 1/2, you're basically just adding your exponents, which is going to be a 14 over 2, or just a 7. And then we're going to divide by 2. We got a 2 there. And then I have minus, and it's going to be the same thing. 13 over 2, and that's to the 1/2, so 2 to the 7 over 2. So those both go to negative 2 to the 6. Whoops, I left my I off. Negative 2 to the 6 minus 2 to the 6I, which 2 to the 6 is 64. So negative 64 minus 64I. Okay, so you definitely don't want to make this number appear into a decimal. You want to leave it as a radical or with a fractional exponent. Otherwise, you're not going to end up with 64 for your final answer. You'll get something that's close, but not the exact answer. And you could have left it as the square root of 13, the square root of 2 to the 13th, and then simplified it later. You didn't have to make it your 2 to the 13 over 2 if you didn't want to. Okay, so let's look now at the roots of complex numbers. Every complex number except for 0 has 2 square roots, 3 cube roots, 4 fourth roots, 5 fifth roots, and in general, nth roots. Okay? It matches up with the root that you're looking for. 3 is cubed, 4, you have 4 roots, you have 5 fifth roots, etc. The angles of the square roots differ by 180 degrees. The angles of the cube roots differ by 120 degrees. The angles of the fourth roots differ by 90 degrees. And the angles of the nth roots differ by 360 divided by n. So you're just going to take 360 and divide it by however many roots you're looking for. So we want to find the 4 fourth roots of 16 CIS 60. So on this one, we're going to start off by using De Mort's theorem. So we're going to say 16 CIS 60 degrees to the 1/4. So we're going to make it 16 to the 1/4, and then CIS 1/4 times 60. Just like we were using his theorem earlier. The 1/4 gets raised, the 16 gets raised to the 1/4. The 1/4 is the exponent for the 16, and then you multiply your angle by whatever you're raising it to. So 16 to the 1/4 is 2, and then CIS 15 degrees, because 60 times 1/4 is 15. So that's the first one, but we have to find 4 of them. So we're going to take 360 and divide by 4, and you get 90 degrees. So now we're going to add 90 degrees to our angle. So 90 plus 15 is 105. 105 plus 90 is 195. Then we add 90 again, and you get 285. And if you added 90 again, you'd be over 360. And we're only looking for 4, so we stop after the 4th one. So those are the answers that they are looking for. You do have to have all 4 of them in order to get it correct. This 2 out front doesn't change. The only thing that changes is the angle. Okay? Looking at another one. Find the 5/5 roots of I. So for this one, we have to put it into CIS form. So we need to know where I gets graphed. Well, I is like one I. You're going up 90 degrees, basically. The length of this is a 1, so you have 1 CIS 90 degrees. It's the same thing as I, because I gets graphed on the y-axis. So we have 1 CIS 90 degrees to the 1/5, because we're looking for the 5th roots. So we're going to say 1 to the 1/5, CIS 1/5 times 90. So 1 to the 1/5 is 1, and then CIS 1/5 of 90 is 18. So that's the first one. Now the next ones, we're going to say 360 divided by 5, because we're looking for the 5th roots, and that's a 72. And so we're going to add 72 to 18 to get 90 degrees, and then we're going to add 72 again to get 162, add 72 again to get 234, and then add 72 again to get 306, and that's the 5th one, and so those are our 5 answers. Okay? So you have to put it into CIS form before you use his theorem. Looking at the next one, find 2 square roots of 1. Well, we have to put it in CIS form. If we graph 1, we're just going to go over here. And so that's going to be 1 CIS of 0. And we're raising it to the 1/2 because we're taking the square root. We're looking for square roots. So we're going to say 1 to the 1/2, and then CIS 1/2 times 0 degrees. 1 to the 1/2 is just 1. CIS 1/2 times 0 is 0 degrees. Okay? Now, we need to take 360 and divide it by 2, and that'll give us 180. And so we're going to add 180, and we get 180 degrees. Now, we only have 2 because we're dealing with square roots, so these are our 2 answers. Now, if I put these into rectangular form, 1 CIS 0 is just 1. That's what we graphed right here. 1 CIS 180 is over here, and that is just basically a -1. What are the square roots of 1? Plus or minus 1, positive or -1. That's what we just found. Okay, so that's how these work. The 2 square roots of 1 are 1 and -1, but in polar form, 1 CIS 0 and 1 CIS 180. Okay, so now we want to find the 3/3 roots of -1. So we're going to start by graphing it. -1 gets graphed over here. And so that's going to be 1 CIS 180 to the 1/3, because we're looking for the 3rd roots. So we're going to say 1 to the 1/3, CIS 1/3 times 180. And when we simplify that, 1 CIS 60 degrees. Now we say 360 divided by 3, that gives you 120. So we add 120, and we get 1 CIS 120, and then we also get 1 CIS 300. And so those would be your 3 answers. And you could, again, put those in rectangular form by figuring out what the cosine and sine of 60 is, the cosine and sine of 120, and then the cosine and sine of 300. So sometimes it will ask you to put them into rectangular form. So make sure that you do that if it asks for it. Looking here, find the 4 4th roots of 42 CIS 40 degrees. So on this one, we're going to say 42 CIS 40 degrees to the 1/4. So we're going to have 42 to the 1/4, and then CIS 1/4 times 40. So 42 to the 1/4. I don't know that off the top of my head, so I'm going to plug it into my calculator. And it gives me 2.55, and then CIS of 10 degrees. Now we do 360 divided by 4, and that gives me 90. So I'm going to have 2.55 CIS 100 degrees, 2.55 CIS 190 degrees, and then 2.55 CIS 280 degrees. And so those would be your 4 fourth roots. So that's basically how you use his theorem to find complex roots or complex numbers. You're dealing with your roots. So hopefully that makes sense to you. On your homework, you don't have any to omit, so make sure that you do that tonight so that we can go over any questions you have tomorrow.